Good afternoon, everyone. My name is Brandon Selbig, and for the last year, I have been working on research with Professor John Call of the UWM Atmospheric Science Department, and this is my project called Climatology of Peak Wind Gusts around Lake Michigan. Winds and wind gusts, believe it or not, are a risk in everyday life from aviation to construction. Especially so, winds and wind gusts play a major role in hazards around lakes, as it can enhance wave heights, which can disrupt shipping lanes for lake traveling companies, as well as affect lakeside shorelines and the cities that live along them. Unfortunately, there is little confidence in current methods in forecasting wind gusts due to it being such a small-scale feature and having to have large data retrieval must be done to better forecast. But I believe my research will show there is a way to better forecast gusts and help reduce the risk. What I did for this project was take 15 different National Weather Service sites around Lake Michigan, and using computer scripts I wrote, was able to automate the downloading and retrieval of 1-minute wind observations from 2010 to 2017. This created a large data set for each site, as over 4 million 1-minute wind observations for each site are taken to construct mean wind speed, direction, and a peak gust for each hour for around 60 to 65,000 hours per site. From the data retrieved, I was able to make gust factor web plots, which I'll explain in the next slide, as well as a climatology of each site around the lake, which together gave spatial and temporal patterns of winds around Lake Michigan. So as mentioned in the previous slide, this here is a gust factor web plot, which I'll explain just a little bit. So starting from the middle of the circle and moving out, we have concentric rings of mean wind speed starting at 0 to 5, 5 to 10, 10 to 15, and greater than 15 knots. And then starting from the center line and moving clockwise, we move in 30-degree bins of wind direction. And for each bin and each ring, there is a calculated gust factor. But what exactly is a gust factor? A gust factor is the ratio of peak wind gusts to wind speed. Other research has been done by Professor Call and Austin Harris that has shown that gust factors can be used in forecasting with very high confidence. If you multiply the gust factor by the forecasted wind speed, you are able to get a number for the potential peak wind gusts in that area. For example, this site here for KUGN has a very large gust factor of 2.31 when winds are out of the west-southwest, and when the mean wind speed is greater than 15 knots. So for example, a wind speed of 20 knots from KUGN from that direction would give a peak wind gust of 46 knots or 53 miles per hour. So with all the gust factors constructed over each wind speed and direction for each site, I constructed an average gust factor for each site and applied it to this map here. By taking the average gust factor, we can look at not only the gustiness for one site, but the multitude of sites and how that lays over the lake. From this map, we can see that results show that the lake is at its gustiest at the north and south ends of the lake, rather than the middle. This makes meteorological sense in some way in that the ends of the lakes we could expect to see more vertical mixing and turbulence, which would enhance overall strength of winds. Another way to look at the results is again to apply the idea like in the web plot example, where we can see how wind gusts are at each site when the mean wind speed is at its strongest. So taking the largest gust factor of each site when the mean wind speed is greater than 15 knots and applying it to the map here, we can see where the strongest wind gusts are and where they're coming from. As you can see, there is no clear pattern or trend of strong gusts around the lake, but knowing the strength of the wind as well as the direction the strongest gusts would be coming from can help forecasters better predict peak wind gusts. For example, the strongest wind gusts from Milwaukee would be coming from the southwest and moving onto the lake. Lastly, I constructed a climatology of winds for each site around Lake Michigan. The climatology was overall consistent across all the sites, and the climatology for Green Bay here was a good example of that. From the climatology, we can see that the lake is at its gustiest during the winter and spring seasons, with winter winds staying consistently strong during the night hours, while winds ramp up during the spring daytime hours, which is consistent with springtime convection. Winds look to be at their weakest during the summer months, primarily during the nighttime, which leaves us with those calm summer nights around the lake that we all enjoy. So by looking over the spatial and temporal patterns of winds around Lake Michigan, we can conclude that Lake Michigan is at its gustiest at the north and south ends of the lake, while having no clear trend when winds are at their strongest. The lake over a year is exceptionally windy during the summer and winter months, while not as much so in the summer. Overall, I believe that the gust factor method can be implemented around the Great Lakes, such as Lake Michigan, in order to better forecast and reduce overall risk from aviation to wave heights. Thank you all for listening, and I hope you have a wonderful day.